Okay, so we're going to talk about the trigonometric or polar form of complex numbers. So something kind of weird to think about is that complex numbers cannot be organized like real numbers. So for instance, like you know that these real numbers are out of order, 1, 2, 3, 4, 6, 5, 7. We know this order, but complex numbers, because they have this real and imaginary part, it's like how do you order these? So yeah, we don't have like an actual way to organize them like real numbers. So we have to do different things. So one way we organize them is by graphing them. And so this is how we can graph them. We can use that standard like rectangular coordinate system, but we tweak it. So the x-axis becomes now the real axis. So if I have the coordinate a, so if I have the complex number a plus bi, the a part goes on the real axis, and then on the y-axis now becomes the imaginary axis. So the b part goes on the y-axis. Now, complex numbers, they correspond with vectors, okay? So let's say that we have x plus yi, some random complex number. So, maybe here's the x part, here's the y part, so I plot it here, boom. Well, complex numbers, they correspond with a vector, so actually we want to have the corresponding vector to go with this. And so since we know that a complex number is a vector, you might not see like the arrow notation always, because we just know that this is a vector. So just kind of an FYI with that. Okay, so let's take a second to practice this. So let's add 3 plus 2i and 2 minus 5i, and then let's graph both of these and the resultant. Okay, so if I sum these two up, so 3 plus 2 is 5, 2i minus 5i will give me negative 3i. So if I want to graph this now, so 3 plus 2i, so here's 3, here's 2, and I draw the vector going here. And then what about 2 minus 5i? So here's 2, here's negative 5, so there's 2 minus 5i, and then finally 5 minus 3i, here's 5, and here's minus 3, so I can graph like that. So I think it's pretty straightforward if you've graphed some vectors in the past. Now, going back to this picture that I showed you, so with the corresponding vector, so this length here is called r, we label it as r, and then this angle here made between the x-axis and the vector is theta. And this should look familiar, we've talked about this in some other videos. Now, this should not be surprising either. So the x part of this can be found by taking r times cosine theta, and the y part of this can be found by taking r times sine theta. And that's just like your basic right triangle trig. Now, r can be found by taking the square root of x squared plus y squared, and if you think back to like back in the day when we were looking at standard form with just angles and stuff, that like very similar idea. And then tangent of theta is found by taking y over x, and of course x cannot equal 0. Okay, so complex numbers, I'm saying all this because complex numbers, they have another form that is generated off of all this information that we've looked at so far. And the other form is called the trigonometric or polar form. You could use either term. So if I take this information here, so where I have x plus yi, I can basically replace the x with r cosine theta. The y I can replace with r sine theta. And then you'll notice that both of these have an r in them, so we can factor the r out. So the trigonometric form of the complex number, so if I have x plus yi, I could alternatively write this as r times cosine of theta plus I sine theta. And this expression, cosine of theta plus I sine theta, this is abbreviated as CIS theta. So we could rewrite this entire expression as RCIS theta. Okay. So just a couple other things about this. So in this formula, or in this form, r is what we call the absolute value or modulus of x plus yi, and theta is what's known as the argument of x plus yi. Those are the terms. So now what we're going to do is just play around with going between these two forms, basically. So let's say that I have one of these trigonometric forms, 3 times cosine of 300 plus I sine of 300. And I want to write this in rectangular form. Okay, this is actually pretty easy. So using the unit circle, I know that cosine of 300 is equal to 1/2 and sine of 300 is equal to negative square root of 3 over 2. So I can now replace cosine of 300 and sine of 300 with these values so that I get 3 times 1/2 minus, don't forget the I times square root of 3 over 2. And then I can just distribute the 3. And now look what I have. I have that classic complex number form. So if we know the polar form or the trigonometric form of the complex number, we can just really easily convert it back by using our calculator or the unit circle. Now, it's a little bit harder to go from rectangular form into the trigonometric form. What you're going to want to do is you're going to want to make a sketch. And then after you've created that sketch, find your R and then find your theta. It's pretty straightforward, but it's just a little bit more work than going the other direction. So remember all of this. You might want to have this kind of in front of you, maybe pause the video and write this down if you need to. And one other thing that I just want to mention, theta needs to be the least positive number. So sometimes you might have to make adjustments to it because your calculator might give you something that is not the right form. Okay, so let's just do a couple of examples now. So let's say I want to write the following in trigonometric form, negative square root of 2 plus I. Okay, so if I draw a little sketch, here is this situation. And so now I want to find my R. So I can see that my x is negative square root of 2 and my y is equal to just 1, right? 1 times I. So I can use my form square root of x squared plus y squared and plug those values in, negative square root of 2 squared plus 1 squared. And if I do the math here, I will get that R is going to be equal to the square root of 3. Okay, now tangent of theta, so to find theta, we take y over x. So what I'm going to do is I'm going to take 1 over the negative square root of 2. I could rationalize this if I want. Now, I cannot get to this on the unit circle, so I had to use my calculator to help me with this. And my calculator gave me, and I just went ahead and rounded the result, negative 35 degrees. Okay, so far, here's the information I have. R is equal to square root of 3, theta is equal to negative 35 degrees. But remember, I told you that this needs to be a positive number, so we have to find now the coterminal angle with negative 35 degrees. In other words, we just add 360. So I take theta, and now I add 360 to it to get 325. So my theta is actually 325 degrees. So now I have all the information that I need, because ultimately what I'm trying to do is I'm just trying to fill in this format of my trigonometric form, right? So I replace my R with the square root of 3, and I replace theta with 325 degrees. Bada bing, bada boom, you're good to go. And then don't forget I told you about that shortened form, so I could rewrite all of this as square root of 3 CIS 325 degrees. Okay, so let's try this again. So I want to write the trigonometric form of negative 12. Kind of strange, right? There's no I in it. So we can actually just assume that negative 12, if I want to write it in its complex form, it would be negative 12 plus 0I. So you can always just make that assumption if you are missing part of that complex form. Okay, so if I were to graph this, so here would be the situation, right? Negative 12, there's my vector. So from this, I can see that the x value is negative 12, the y value is 0. So if I just plug this into my R formula, I get that R equals 12. And then for tangent of theta, so I have 0 over negative 12. And so that would mean that tangent of theta is equal to 0. So my theta will be equal to 180 degrees. Now maybe you're saying, wait, why wouldn't theta be equal to 0 degrees? So remember, this x part is negative. So if you just think about where this is going to fall on the unit circle or what makes the most sense, this has got to be 180 degrees. So you can look at the unit circle if you want to just kind of confirm that. Okay, so now I've got everything I need, right, to finish this. So R cosine theta plus I sine theta. So I can just plug everything in. So there's everything plugged in. Or again, I can do this shortened form of 12 CIS 180 degrees. Okay, so now we've kind of seen everything. So what I want to suggest now is that you just write the next two examples in their alternative form. So let's say that I've got 8 times cosine of 210 plus I sine of 210. So I want this in the complex number form. So I think you should try this. Remember, I always say math is not a spectator sport. So don't be scared, give it a go, hit play when you think you've got it. Okay, so I just used the unit circle to find the values of 210, cosine of 210, sine of 210, so they're all listed here, and then I just have to distribute the 8. So the complex number would be negative 4 square root of 3 minus 4i. Okie dokie. So now I've got the complex number, so now I want to put this in the polar form or the trigonometric form. Again, I think you should pause the video here. Just make sure that you are good on this. Hit play when you're ready. So here's my sketch, and so if I find my r, this is going to be negative 8 squared plus 5 squared, so this comes out to the square root of 89. Okay, next I've got to find tangents. So tangent of theta, this is going to be y over x, so 5 over negative 8. So if I use my calculator to figure this out, I get negative 32 degrees. Okay, so once again, I know that that's an issue, so I need to add 360 to this. So I did 360 degrees minus 32 degrees. It's the same as adding negative 32 degrees. And so I get 328 degrees. So that's going to be my theta now. And so I could just go ahead and plug this into the formula and I get what you see here. And of course you could write that in the shortened form if you wish. However, I did not, just for the sake of space. Okay, and so that brings us to the end of this video. So it's a short and sweet one. So thanks for watching, guys. I will catch you in the next video.